Today we're going to solve the LeetCode question, longest palindromic substring. So given a string S, return the longest palindromic substring in S. So for example, if we have BABAD, the longest palindromic substring in this would be BAB of length 3, where ABA is also an answer. We also have CBBD here, and the longest palindromic substring is BB of length 2. So one way we can go about this is a brute force way, where for each character, for example BABAD, we would check if it makes a palindrome with the rest of the characters here. So if we look at the first character B, does it make a palindrome with A? No. Does it make a palindrome with B? Yes. So our result would be BAB. And then we check the rest of the string. Does it make a palindrome with BABA? No. BABAD? No. So our result would be BAB for this iteration. And we continue with the rest of the string. But for each iteration, while we're checking if it's a palindrome, we'd have to, as I said, check if it's a palindrome. And this runtime would be O of n. So along with the O of n squared of iterating through this entire string, it would take O of n to check if it's a palindrome. So in total, it would be O of n cubed runtime. But there's a better way to do this. So another way to do this is akin to longest common substring, where through dynamic programming, where given B, A, B, A, T, and then reverse the string D, A, B, A, B, we would see that the longest common substring would be BAB here, and we would also see it would be ABA here, and those would be of length 3. So this would be O of n squared time complexity and O of n squared space complexity to store this dynamic programming table. But there's an even better way with O of n squared time complexity. We'd have constant O of 1 space complexity. And I'll show you how. So if we notice for a palindrome, let's take the sample here. So one thing about a palindrome is we take the middle and we check if an easy way to check if it's a palindrome is we expand to the left, to the right, and check if these characters are the same. If they are, then it's great, it's a palindrome. And we continue until either the string is out of bounds, or if two characters differ. So if you take the CBBD here, if the palindrome is of even length, we look at BB, and we expand out to the left and to the right, and since these are different characters, we accept this as being the palindrome. And if we have an odd length palindrome, like A, B, A, B, Q, we look at this middle character here and expand to the left, expand to the right, they're the same, great, palindrome, and then expand even more to the left, more to the right, and since these are not equal characters, we accept BAB as being this palindromic substring. So to check this, we would only have to iterate through this the string. So we have to iterate for each character here, and for each character we expand around the center towards the left, towards the right. And similarly for A here, towards the left, towards the right, until we find the longest palindromic substring. So this initial iteration through the string here, along with the expanding around the center, they're both linear time, so in total this would be O of n squared time complexity. And we only need constant variables to store the position we're at and the result variable, and so that space complexity would be O of 1. So to code this up, I want to initialize my result variable here. I'll have it be empty first, and then we can iterate through the string s. So what we want to do is account for both cases of the palindrome being even and odd. So if we have A, B, B, A here, this is a valid palindrome of even length, and we want to expand out from these centers. So these are the midpoints, and we want to expand out from them. And including here, this could be a valid palindrome, but we want to try expanding out from here. Similarly, for the odd length, we want to expand out from this single point here and check if on either side if the characters are the same. So what I want to do is create a couple of helper functions here to cover both these cases. Now, passing a string and the position from where we want to expand from. I'll initialize the left and right pointers. They're the ones that will actually expand. And while left is greater than or equal to 0 and right is less than length of s, we want these pointers to be within the range of s, and s left is equal to s right. So we want the characters to be the same, because if they're not, then it's not a valid palindrome, and we want to break out of here. I'll keep expanding. Left minus equal 1, right plus equals 1. So I'll keep expanding from the center here. If we have a center like ABA, we want to expand to the left and to the right. And then what I want to do here is return left plus 1 and right minus 1. We want to do this because I'll go back to this example here. So if our left and right pointers are here, that's all good and valid, and then our left pointer will go out of bounds and our right pointer will go out of bounds, and that's when it will break out of this while loop. But we want to take into account the ranges within the position s. So length is minus 1 because it's out of bounds here, and right would be 3. I want to return left to position 0 and right to position 2. So return left plus 1 and right minus 1. And same idea. Here I want to cover the case where the palindrome is even and expand out from the center, starting from not 1 but 2 characters. And I could actually pass in actual left and right pointers here because they won't necessarily be in the same position of s. Left is equal to 0 and right. Make sure it's in the range of s, and make sure it keeps on being a good palindrome. I'll continue expanding. Okay. In our main loop here, where we're iterating through s, I'll call, let's say, the odd case first. And if the length of the palindrome within S that we expanded around, if right minus left plus 1 is greater than result, I'll have result be S within the ranges of left and right plus 1. Because on Truman string, this last position here is not inclusive. And I want to do the same thing here for the case where a palindrome is even. S, and I want to pass in I and I plus 1. So what I want to check here is if left is less than or equal to right, and same thing as up here, and the substring is greater than the result we have so far, I'll assign result to be equal to S left right plus 1 to this substring here. So why did we do this? Well, we want to, so since we're covering the case here, let's just start with this for now. So we want to check in the even case if this is a valid palindrome. So let's say we're at position 0. And left and right corners would be left equals 0, right equals 1. So expanding out the middle, we would have, actually we wouldn't expand out from the middle at all. These two are different characters. So we would break out of this while loop and we would return left plus 1 and right minus 1. But the problem is left plus 1, we will return left equals to 1 and right is equal to 0, which it obviously doesn't really make any sense. So that's why we have this check here, if length is less than or equal to right, because we can't have this substring where left is beyond the right position. So we're doing that. We should cover that case and then return result finally. Okay, and barring any bugs, I'll try submitting for I and Ray. Okay, and there you have it. Thanks for watching.